Hi there. Okay, today what I'm going to do is I'm going to do a few different demonstrations. One of them being I'm going to demonstrate 3 different instruments and gauges that we make. They are obtainable, but available, should I say, but not easily obtainable. They're not that widely used, but they are needed if you sort of into repair business or DIY, or you want to do the maintenance on your guitars or musical instruments, or you will see as we go along the applications and why you require them, why you need them. Okay, let me start with this. Okay, first of all, the first instrument I'm going to do the demo would be the magnetic polarity display. And I'll be able to determine by bringing this step of the instrument, and the whole sort of secret is inside this actual blob, the chip, surface mount components and so on, that they actually determine and measure with the sensor the polarity and displays it with the LED. Okay, right now it's the last measurement was north magnet. Now I've got 2 magnets over here, okay? One is definitely south, the other one is north. So right now it's on north. So if I bring it to south, a red LED should come, and watch what happens when I bring it closer. You can see it. It's a red LED, okay? Watch when I bring it to north. Okay, watch now when I bring it to south. Okay, watch. Okay, now this is guitar pickup. Now, this guitar pickup is for acoustic guitar, but nonetheless, I'll come back to it now. We'll come to it just now, after I demo the 3 instruments. And what they used also on the guitar pickups and so on. Now, each pickup has got the winding and the magnets inside. Now, this one, it's a single coil and a single magnet. Now, I would like to see what polarity is this particular sort of magnet that's inside, that's on top. And watch now what happens when I bring it closer. Tells me it's a south, S for south. Okay, so I know that this magnet here is my sort of where the strings come over here, the strings that they come over there, 6 strings, are facing the actual north pole of the magnet. Of course, any magnet can be reverse polarized. We can reverse polarize it if need be, without stripping the actual, pickup and things like that. Or there is different sort of techniques by reversing wires on the coil to change the polarity, because depends of what like in this case, it's a south on top, underneath, under the string, each string, okay? That will generate specific voltage on the actual coil, which we will measure on this instrument, and you will actually see it, okay? And then we can see, is the coil, and more so if we have got, say, more than 1 pickup, say maybe 2, say the bridge, middle, and then you get the neck, pickup. Of course, some of them they use 2 pickups, some of them 3, some of them 4, and so on. Some of them use dual pickups, like a humbuck, which is usually close to the bridge. And the reason why they call it a humbuck, because what it does, it kills the hum, the actual noise picked up by the adjacent, because it's a dual pickup. So the noise gets cancelled between the 2 sort of pickups, which is within one housing. But nonetheless, okay, so that's one way of measuring. Let me do it one more time. Okay, that's south, and we got it over there, it's south. Okay, watch north. Okay, north. Okay, this is the electronic one, very precision, but it's pricey. Of course, it comes at a price. And then we got the south. Okay, now what I'm going to do is, okay, I'll put it here on the side, then we're making exactly the same thing, instrument that does exactly the same thing, except maybe not as sensitive as this one, the electronic one. But nonetheless, even this one here, which is like much cheaper than the electronic one, will give you a fair degree of accuracy. And I demonstrated on the pickup, and demonstrated north and south, and we established that this is south with the electronic one. Now, if you look at it over here, okay, magnetic polarity tester. Inside, if you see the white like it is right now, okay, it specifies and it tells you over here that would be the south. Wherever you're measuring at the bottom will be south if you see the white. Okay, and watch now. When I bring it to south, nothing happens. Watch when I bring it to north. Aha! It flipped on to black. And it tells you over here, if it's black color, that would means you are measuring north pole of the magnet that you're measuring. And it is north. And we established that with my fully electronic precision sort of instrument. Okay, so one more time. Okay, that's black. Watch it now. Oops, sorry, it picked up what you call it magnet. It's this is a strongish magnet. Watch it there. It's white. And you can see it. South. Black. Watch it there. Black. It's north. White. South. Now let's try. Okay, I'm just gonna put it to the north. Now remember, at the beginning of the demo, we measured with the instrument, electronic one. We measured the pickup, and we determined that this magnet is the south. So now, right now, it's showing us north because that was the last measurement we've done. Okay, so this bollick inside is showing us black, which says the magnet you measured, that's the north pole. Now this one here, because we know it's a south, it should change to white color. Watch now when I bring it. Can you see it? It's already white. Now let me bring it again. Okay, I change it to north. I bring it to white. I mean to the pickup. You can see it, it's white. So it's north. Okay, we measure it by just bringing close. You don't have to touch. You can if you want, but watch now again when I bring it here. And I'm sure you can see it very clear. Okay. Okay, let me do it over here. You can see it toggles and shows me that this one is out. So I have done the demo of these two instruments. Now, it is exactly the same, basically, right now. Over here, I just want to see. Okay, now I'm going to jump onto testing the coils. Okay, now imagine, and then we'll come to the guitar sort of pickup. How do we test if there is more than one pickup, if they're all of them connected sort of the right way, and that the coils are not out of phase? So let's assume, okay, this is, say, one pickup, second pickup, third pickup, okay? And obviously it's got two wires. It's got a beginning and an end. And sometimes in wiring, you know, it's very easy to swap the wires, type of thing, especially if you put them in series, or, you know, depends how and what type of a sound you want to get. So when you do connect them, you want to make sure that all the wiring is done properly, and all the so as a final result, coming out of the guitar, where you plug in your sort of jack plug that goes into the amplifier, instead of amplifier, it will be it's actually going into the instrument over here. Okay, so without further ado, let's do it. Okay, I'm going to start with this coil here. Okay, this coil has got basically 2 points. Okay, and there's nothing inside. Of course, if it's got a strong magnet like a pickup, you'll see the needle shoot across type of thing. But of course, we're dealing with very, very low signals right now. because when we bring the magnet, let me just put it over here. Watch now, say I'm going to bring, say, the south. No, let's do it with the north, okay? I'm just going to bring it with the north. Watch the instrument, what happens. Okay, you can see the needle started. When I drop it, the needle goes over there, goes to right. Can you see it? Okay. Now watch, when I remove it, it will go to the left. Watch. Can you see it? Now I'm going to bring it again. Okay, it goes to the right. Okay. And that is what one should be striving when you actually test the pickups. But we'll come to a pickup. You should strive that when you drop whatever magnet, okay, not a magnet, when you drop a metal, not a magnet, a metal, onto the pickup. I've done here, I put sandwiched so I don't scratch the pickup, piece of metal which is not non-magnetic, and then we will just bring the metal simulating the strings, and then you will see the needle move. All right, let's, you just bear with me, it's becoming a bit complex, and yeah, you just got to pay the attention, but you can replay the video and you'll understand. Okay, so watch now again, when I remove the magnet, it will shoot to the left. Watch it, can you see it? Okay, and that's how it should be, always on the pickup. When you press on the output of that pickup, you should get, when you bring it close, okay, it should go wherever, to the right, into positive, which means positive signal is connected properly to the actual coil, okay, coming out of the coil, should I say. Now watch, when I remove it, okay, goes, it's called the back EMF, okay. So now we demonstrated on this small little coil. Now let me do it on this big coil. Okay, let me connect it up over here, and you'll see it again distinctly. Okay, now this one doesn't even have any core. Okay, now watch here. I'm gonna do again the north sort of facing. Watch when I bring it. You can see it. It went that way. Okay. Watch again. You can see it. It went that way. Okay, it's a strong magnet. Watch when I bring it again. You can see the peak. It's very fast because it's a back EMF basically, that the magnet, and the faster you bring it, the bigger sort of movement you will get, because you're breaking basically, I mean the magnetic field from the magnet is breaking, you know, should I say, interacting with the windings of the coil, magnified a little bit by the actual core, and then produces the voltage. Simple sort of you know, simple way of explanation of the actual system, the way it works. So right now, one more time, I'm just gonna bring it. Watch now. Okay, watch when I remove it fast. You can see it goes left. So if there is several coils like this connected next to each other, and you would like them to be in phase, okay, you do with the magnet, you just put on each coil, and when you put it, it must go to the right on first one, second one, third one, and so on, you know, and so on. Okay, that means all of them are in phase, without you looking on the wiring and tracing the wires and so on. Okay, so I've already demonstrated sort of on two coils. Let me do even on this one here. This is from crossovers. Okay, let me do it again. Let's see if I connected it up right way. Okay, can you see right now? I'm still using the north. Okay, watch now when I bring it. Can you see first, instead of going to the right, it actually goes into minus. How do we actually... Okay, watch now when I change the polarity, and that's how you would actually rectify if one of the coils is out of phase, by changing the wiring. Now again, I'm going to apply north. Okay, watch now, it will now shoot. Okay, watch there. It's in positive. Watch it. Watch when I remove, to the left. Okay, watch when I bring it, it's to the right. Okay, when I remove, left. When I bring down and touch the coil, to the right. Okay, so which means now this one is in phase. That's my positive, that's my negative. And if I connect up positive with positive, negative with negative, these two coils would be in phase. Okay, and exactly the same thing happens with the pickups. Okay, now let's start with the pickup. Okay, now this particular pickup, as I said, it has got a small little jack plug, but nonetheless, so I'm going to use comes with its own original cord, but just for demo purpose or whatever, instead of using big jack plug, and I can use this adapter, but I want you to see when I swap the wires. Okay, again, by swapping the wires inside, by the volume controls or inside, the guitar, you can actually manipulate each pickup, or should I say that's one pickup, this is a second pickup, third pickup, and so on. Okay, by changing the polarity of the wiring of each pickup, you can actually put them in phase. So instead of subtracting, they can actually keep on adding the actual voltage. Okay, now let's connect it up anyway. Okay, let's connect it up there. Let's connect it up there. Okay, now it's connected. Of course, your volume controls, they have to be at its maximum. Okay, otherwise you attenuate the signal coming out of the pickup going into the actual amplifier. So now we don't use the magnets any longer. Okay, now we use the metal plates. Watch now what happens. Can you see it? It's a very, very, very minute. Let's just do it this way. Sorry. So you can actually see it but better. Can you see it? Okay, watch when I lift it. Can you see it goes into negative? Okay, can you see it? It goes into negative, which means this one is connected the right way. Okay, now let me swap and put, and that's what you want it when you touch. Okay, I can actually even use this plate here that I actually made. Okay, watch now. Now it's going to shoot towards that side. Sorry, it's going to be opposite, to the left. Watch when I remove it, it goes to the right. You don't want that. You want all the pickups that when you put it down, it must go to the right, in other words, to positive, towards number one over here on the instrument. Okay, because it's not it's unwritten rule, let's put it that way. The important thing is, as long all your pickups or all your coils are moving the actual meter in the same direction with the same polarity magnet or with a piece of metal that you apply, like I'm applying, that's not magnetic. If you actually put, there is nothing. Okay, let me show you. That's north, that's south. Now this is non-magnetic. This ruler is non-magnetic. Okay, you can see nothing, no magnet whatsoever. Okay, so as I said, I hope so far you're following what I'm trying to explain, because it's difficult to actually do it in such a short period of time, all these things that I want to do, the demo and so on. But nonetheless, okay, when I bring it, okay, you can see it went to the left. When I bring it up, it goes to the right. Okay, now let's swap the wire again. We don't want it this way, we want it this way. Okay. Okay, let me use this. Okay, watch now when I bring it. Okay, you can see it. And you gotta be fast dropping it. Okay, because as I said, the magnetic field must be broken and once the metal absorbs it, makes a basically back EMF and generates a voltage, and then comes into the instrument which measures that back EMF, which is very small. You're talking like microvolts, stop out in millivolts, sort of. It's not like in voltages that you actually measure. Watch now. Okay, you can see it. Okay. So this pickup, in actual fact, okay, you can see that's negative, and it's in the center, which means this pickup inside the wires, there have to be two wires coming out of the pickup, going into, say, a potentiometer, wherever they are. You just swap them. That's all. Okay. Or what I would do is the screen cable, the screen cable should go always onto the ground. Okay. But although this is screen cable, you just swap it. And that way, there's a second way of doing it. I can remagnetize. And instead of having the south, okay, let me just go. Now it's going to change to south. Instead of having south, I can put and magnetize it to be north. Wherever it's easier for me when I repair the guitar or sort of diagnose or whatever the case may be. And then I remagnetize the magnets and I make them to be the north on top. But nonetheless, for purpose that I want to demo, this is good enough. Okay, so this one right now is no good. It's good, but red should be in the center. Okay, watch now again. Okay, it shows positive on the negative, and the reason why, because this is south. And the way, I don't know how these wires are connected right now inside, but nonetheless, to rectify it one more time, I would just open up two screws and just swap the wires, just reverse them, and that's it. Then the positive would be coming over here. When I bring piezo metal, not the magnet, you don't test the pickups with magnet, you test them with the any metal, which is not magnetized upward in, and that will induce the, okay, you can see it. When I bring it, it goes towards the positive. Okay, so basically that's what, it's all about this little instrument. Although it moves very little, it's very difficult to actually measure it, that voltage to measure with the Fluke digital multimeter, because it is such a fast transient when you bring the piezo metal next to the magnet, which now, coil detects the change in magnetic field and produces that minute voltage which gets displayed. And on the electronic instruments, yes, you will see it, but you have to, it's much easier with a visual moving needle, let's put it that way. So, yeah, basically what I have done is I demonstrated my little electronic magnetic sort of tester, north and south pole. I tested and I demoed. Let me go again. Oops, sorry. Let me just put it here. Okay. Let me do it this way so you can actually see it. Okay, doesn't matter. Okay. Watch now. Oops, picks it up. Okay. Watch now. North, south, white, black, white, black. Watch it over there. It's south. So this is south magnetized. Although there is no voltage, just picks up the magnetic field and this little instrument, which is very handy. So everybody can afford it because it's really inexpensive. Less than half the pizza that you buy for your lunch, it will cost you. But it can save you a lot of headaches, not only in the audio industry or just electronics, also in mechanical engineering and also in biomedical and things like that. And you don't need batteries, and you can carry it in a pocket, so it's no problem. And we do make them, so they're always available. Then, of course, we got this little meter, which actually I never really plugged in the jack plug. Let me just plug in the jack plug, okay, to a small one. Let me do it this way. Watch now, okay, a last test. Okay, so now I plug it in there, okay, watch the instrument, okay. again, I'm gonna use the piece of metal, which is, I just sandwich that so I don't scratch, the pickup when I slam it, it's, so I don't scratch the black color and so on. Okay, watch now. Okay, can you see? When I drop it, it goes opposite to the left. When I pick it up, but you gotta be very fast, okay? When you pick it up, it goes to the right. It shouldn't be like that, which tells me that these wires are wrongly wired inside. Of course, I'm not gonna change them. The reason why, because it's fine. This is used just as a single pickup. But if you got 2, 3 pickups, it's very essential, and then you can correct them just by changing 2 wires where they are soldered. And that's it. And you can put them in phase. You can, with these instruments, you can test if there is an electromagnetic field, and if all of them are, say if this one is south. You can't have, say this is a bridge pickup. Then you get the middle, then you get okay, say this is a bridge. Then you get the middle, then you get the neck, say third pickup and so on. You can't have one south, other one north, or this one south again, or whatever. All of them, they have to be the same magnetic polarity on top. And with these 2 instruments, you can easily measure not only on the pickups, on the coils, more so for inverters, where they have got multiple sort of coils and inductors and so on. So yeah, with 1, 2, 3 instruments, you can do miracles. On that note, I hope I didn't confuse you and muddle you up. And yes, they're available over the counter at the shop. And yeah, you're welcome to do any queries and see the actual demo. You touch it yourself, and then you know exactly what is happening. All right, on that note, I say thank you for watching Batos' demo of these little instruments and how you actually measure the pickups and the actual polarity of the coils and that they in phase if you got more than one and so on. Okay, thank you.